Those chicken nuggets yesterday, phenomenal. But let's get to this last video for this week at least. We're going to do percent change. So it's going to be percent increase or percent decrease. Let's get it. Welcome y'all. To start this out, we're going to look at our percent change notes. So here we have percent increase, where we have our new amount is equal to our original amount plus the percent change times our original amount. So this percent change times our original amount is going to give us the amount that we increased. So this is used when you're trying to pay tax or you're charging an increase. So this is all used with percents, although there are some times that there'll be fractional increase. So again, we're going to be using this formula to help us out throughout all these problems. And then again, finding percent decrease is the same formula, but it's a little different because an increase, you're clearly increasing, so you're going to add. Well, a percent decrease is you're going to use subtraction because you're actually going to decrease. And again, this percent times our original amount is just telling us the amount we're going to decrease. And so we're seeing how much we're decreasing, and then we're going to subtract that from our original amount, or we use that to find out what our actually scratch that. So this is used when having to find a discount or a coupon, all with percents. And then finally, the percent change portion is going to be your new amount minus your original amount divided by your original amount, and that'll give you your percent increase or decrease. If this is positive, then it was a percent increase. If this was negative, it means it was a percent decrease. So this is used when you're trying to find out the percent something increased or decreased by. Again, if this was negative, it's a percent decrease. If this ends up being positive, it's a percent increase. Let's move on to our problems. All right, welcome everybody. So here we're going to do example 1 and example 2. So in example 1, we have a store owner uses the expression below to calculate the sale price of each CD player he is discounting. And so we have R minus 0 and 2/10 times R. And this expression represents the regular price of a CD. So in this expression represents the regular price of a CD player. Which of the following is equivalent to the expression? And so we have 0 and 1/10 times R, 0 and 8/10 times R, 0 and 9/10 times R, or 1 and 2/10 times R. And so here we have the expression R minus 0 and 2/10 R. And so what I like to do is I like to rewrite this here. So what is this telling us? So here we have the original price, right? R represents the original price of the CD player. And here we have minus 0 and 2/10. And so since we're subtracting, this means that this is actually kind of a percent decrease. So this is a percent decrease problem. And so 0 and 2/10, well, what is 0 and 2/10 as a percent? Well, remember, we need to multiply this by 100 in order to go from decimal to percent. That means that this is a 20% decrease. And so we're getting 20% off, right? And so what we want to figure out is what is 20% off of our original price. And so maybe you already see what our answer choice is here, but we're actually going to reason here. I like to ask you all, how many R's is right here? How many R's do we have? Well, we only have one R, right? So that means I can multiply this R by 1, and I still am left with R. So I like to rewrite this as 1 times R minus 0 and 2/10 times R. And so we have two options. First option is I like to ask myself, right, 1R minus 0 and 2/10 R, right? How much, this is subtraction, so how much do I need to add to 0 and 2/10 in order to get to 1? So first off, this is subtraction, right? We know we're not adding, so that already eliminates D, right? Because 1 plus 0 and 2/10 gives us 1 and 2/10. We know it's not D because we're not adding, we're subtracting. That already eliminates 1. Next up, we have 1R minus 0 and 2/10 R. What do I need to add to 0 and 2/10 to get to 1? Well, I cannot add 0 and 1/10, right? Because that'll just give me 0 and 3/10. That doesn't make sense. And so this leaves us with B and C. And so if you're getting 20% off, clearly that means that there's 80% left, which does leave us with B. And so let's figure out why it's B. There's two things here. Either you can just combine like terms and just be like, okay, this is 0 and 8/10 times R and be done. Or you guys can be fancy and factor out these two terms. And so I can have 1 minus 0 and 2 tenths. And we're going to still times r. So all I did was factor out the coefficients from both of my variables. And so I have 1 minus 0 and 2 tenths times r, which ends up just giving us, again, 0 and 8 tenths times r. And so now let's look at example number 2. So Jordan's dog weighs pounds. So Jordan's dog is being weighed in pounds. Emmett's dog weighs 25% more than Jordan's dog. Which expression represents the weight in pounds of Emmett's dog? Well, first off, we know that the weight is going to be represented as P. And so we have the amount that Jordan dog weighs. We know Emmett's dog weighs 25% more than Jordan's dog. And so we don't know how much Jordan's dog weighs, so we can represent that as P. And so what that means is that we have Jordan's dog, which can be represented as P. And then we're saying that Emmett's dog weighs 25% more. So more means addition. And so this means we want to add 25% more, but we want to make sure to have the same variable because it's 25% more than Jordan's dog. And so this P represents Jordan, while this expression here represents Emmett. And so now when I look at these, right, how many P's do I have here? Well, there's one P here. And so what that means is I can combine like terms. And so moving forward, this could just be, right, 100% of Jordan's dog, right? Because there's one P. We know 1 as a percent is 100. And now I can combine like terms. And so this can just become 125% times P. And that would give me the weight of Emmett's dog. And so, well, Emmett's dog, I guess, how much they weigh more. And so again, I can actually make this part into a decimal first. And so we have Jordan's dog, which is just 1P. So we can do 1P if we want. Plus 25% as a decimal. Again, 25% as a decimal is just 0 and 25 hundredths times P. And so I can combine like terms again. And so it can look like something like this by factoring it out. And I end up getting 1 in 25 hundredths times P. And here are just a lot of examples of what to do. And so when I look here, this is 0 and 25 hundredths P. Well, that's just the expression for how much more Emmett's dog weighs, right? The additional weight Emmett's dog weighs. And so that's not it. That's not equivalent. Here we have 1 in 25 hundredths times P. That's actually what I got here. This is saying that Emmett's dog is 25% more than Jordan's dog. So this is actually one of our answers. Here, this is P plus 0 and 25 hundredths. Do you notice how there's no P here? Since these are not like terms, meaning that they have the same variable and exponent, you cannot combine them. So that means that this is not equivalent because this is simplified and this expression here will not equal 1 in 25 hundredths P. Again, this is another throw up. Here they say 1 in 25 hundredths plus P. Again, these are not like terms, so you can't combine them. This is 1 in 25 hundredths times P, not plus P, so that's not an answer. And then finally, we have P plus 0 and 25 hundredths times P, and this is our second answer because it matches what we got here. And again, these two questions most likely are going to be on MCAS, and we just want to go through them for y'all today. Quick little side note for y'all. Spindrift, if y'all haven't had this yet, bro, it's it. All right, here we're going to do example 3. A worker at the zoo calculates the amount of fish in pounds needed for the weekly diet of a bear. The bear eats 105 pounds of food each week. 25% of that weight must be fish. What is the total amount of fish in pounds that the bear should eat each week? This goes back to a prior lesson we did. We need to figure out what 25% is 105 pounds. Why? The bear eats 105 pounds of food each week. 25% of that is fish. So this is just going to be a percent equation. So I'll show you both. Here on the left, we're going to do proportions. So here we have that, remember we want to do our percent is equal to our parts over our whole. And so our percent, the amount that is fish is 25%. And that is equal to, right, our part, which we don't know the amount of fish we eat, over our whole, which is 105. And remember, percent means per 100. So this is just 25 over 100 is equal to x over 105. And again, we have two fractions separated by an equal sign. So we need to cross multiply. And so this becomes 100 times x, which I'll do this little line here. It's just 100x, and that is equal to 25 times 105. Again, you're probably going to have to do this on the side. So I do 105 times 25. And again, we do our side math here. So 5 times 5 is 25. Regroup our 2. Sorry that there's not enough room. I probably should have planned that ahead of time. 5 times 0 is 0 plus 2. 5 times 1 is 5. We move over a place value to go over to the tens place. So we have to add a placeholder. 2 times 5 is 10. Regroup our 1. Bring down. 2 times 1 is 2. Add these up. And so that's 2,625. We see that we had, and so that just means it's equal to 2,625. I almost gave the answer ahead of time. And so now we just divide both sides by 100. And so we're left with x is equal to, remember when we divide by 100, it just means we move the place value over twice. And so this means this is 26 and 25 hundredths. So that means the bear eats 26 and 25 hundredths pounds of fish. Again, we could have also done our percent equation, which is just part is equal to percent times whole, right? Remember, 25% of 105, of means multiplication. And so we don't know our part. This can be 25% times 105. Remember, to get this percent as a decimal, we divide it by 100, which moves the decimal place over 2 times. And so this means this just becomes x is equal to 0 and 25 hundredths times 105. And so we're left with x is equal to whatever these two are. We already found that. That was here. But I'm going to show you again just because there's more room this time. So we have 105 times 0 and 25 hundredths. We see that we're multiplying by 25 hundredths now, which means we have two place values in our factor. So we're going to have to add that back into our product. And so we do this again. 5 times 5 is 25. 5 times 0 is 0. Plus 2 is 2. 5 times 1 is 5. We're moving over a place value to go to the tens place. So we add a placeholder. 2 times 5 is 10. Regroup our 1. 2 times 0 is 0 plus 1. 2 times 1 is 2. We add these up. And we get our same answer. But remember, we had 2 decimal places in our factor. So we add that back into our product. And so we end up getting x is equal to 26 and 25 hundredths. And so that's the amount of fish that the bear eats. Now, the zoo increases the amount of food the bear eats each week to 120 pounds. What is the percent increase? Again, this is an increase because we increase the food by the amount of food that the bear eats each week. Round your answer to the nearest percent. So here, our new amount, I like to do new amount, I like to make a key, is 120 pounds. Now, this is what messes up a lot of students, is they go back up here and think their original amount was the 26 and 25 hundredths. Our actual original amount was the original amount that the bear ate, which was 105. And so our original amount is the amount we started with. So that's 105. And so we got this from our first page, is our new amount I'll do that as NA minus our original amount, we'll do OA, divided by our original amount is how we get our percent change. And so here, our new amount was 120. So we do 120 minus our original amount of 105 divided by 105. And that is going to be equal to 120 minus 105, which is just 15, over 105. Now, I'm going to need a long divide to get this. I could simplify this by 5 first if I wanted to, but yeah, why not? Let's simplify it by 5. So I divide both of these by 5. I know I can divide both of them by 5 because um, both of these end in 5, so I know that I can simplify it by 5. This ends up becoming 3 over 105 divided by 5 is just going to be 21. Whoa, I can now simplify it by 3 as well. Wow, I didn't think it was going to get down that far. So I simplify it by 3, and I end up getting 1 over 7. And now what I want to do is I just want to get this as a decimal by doing long division. And so here I put the 7. Well, the 1 is my numerator, so I know that's my dividend. So the 1 goes inside our division symbol, and the 7 goes on the outside. And so we simplified this because now it's easy to get to a decimal. 7 goes in a 1 0 times. So I add a decimal and bring it up to my quotient, and then add a 0. 7 goes into 10 one time. And so 10 minus 7 is 3. Remember, this wants it to the nearest percent. So we're going to get to 3 decimal places and then just stop. And so 7, so now we add our 0, carry it down. 7 goes into 30 4 times. And so we end up getting 28. 30 minus 28 is 2. Carry down our 0. 7 goes into 20 2 times. And so we end up getting, right, an approximate answer of 0 and 142 thousandths. Now I get this as a percent by multiplying it by 100. And so that moves the decimal place over to the right twice. And so that means that we increase the food by approximately 14 in 2%, which just means that we approximately increase the food by 14%. Bam. 14%, I should say, increase. Now is this problem? Here we have some annotation already done, but every 5 years in March, the population of a certain town is recorded. We call that a census. In 1995, the town has a population of 4,500 people. From 1995 to 2000, the population increased by 15%. From 2000 to 2005, the population decreased by 4%. What is the population in 2005? And so I already scaffolded this problem for you. On MCAS, you guys probably wouldn't have these already separated. But what I want you guys to see is we're going to have to do this increase first to get what the population is in 2000. And then once we know the population in 2000, we can do our percent decrease. And so I have both the equations here. And so let's get started. Now, here we want to do our new amount. Do we know our new amount yet? The answer is no. We don't know the population yet in 2000. And so our original amount was of 4,500 people. And this is a percent increase. So we want to add the percent change of 15% times our original amount of 4,500. Now, what's important is we want to actually use PEMDAS, right? You want to do multiplication before you add. A lot of students will just add these together and then get the wrong answer. And again, what this is saying is how much we increase. So amount increased. How many more people are we going to have? And so in order to do this, I need to do 15% as a decimal. So this becomes x equals 4,500 plus I need to divide 15% by 100. That moves the decimal place over to the left twice. And I'm left with 0 and 15 hundredths times 4,500. And so now I need to multiply these together. So again, I'm just going to have to do that on the side. So 4,500 times 0 and 15 hundredths. Again, I have two decimal places in my factor, so I have to make sure I take account of that because that's going to have to go back into my product. And so 5 times 0 is 0, 5 times 0 is 0, 5 times 5 is 25, so I regroup my 2, 5 times 4 is 20, plus 2 is 22. And now I'm moving over a place value to go from the hundredths place to the tenths place. And so whenever I move a place value, I need to make sure I have a placeholder. And so 1 times 0 is 0, 1 times 0 is 0, 1 times 5 is 5, 1 times 4 is 4. I can now add these together. 2 plus 5 is 7, 2 plus 4 is 6. And I make sure to add my two decimal places back into my product. So that goes 1, 2. And so what this says is we're actually going to increase by 675 people. And so when we found 15% of 4,500, that gives us the amount we increased. So we increased by 675. And now I can add these together. Maybe you do that on the side. 4,500 plus 6,000. I lied. 675. And so 0 plus 5 is 5. 0 plus 7 is 7. 5 plus 6 is 11. Regroup our 1. 1 plus 4 is 5. So this tells us that the new population in the year 2000 was 5,175, which means we increased by 675 people. Sometimes MCAS is going to be like, okay, we're going to do this percent increase. How much did you increase by? What's your new amount? A lot of the time, students will get like the new amount and then they get confused because they're like, oh, how much did we increase by? Um, this amount is the amount you increased by. So you want to know how much you increased by or how much you decreased by. And so what's important now is we're going from the year 2000, 2005. So now this becomes our new original amount. So I bring over the 5,175. This time we're decreasing by 4%. Also, one thing to note is if we just multiplied 4,500 by, let's say, 1 and 15 hundredths, we would also get the same answer. Why I don't like to show that is because we did that over here. It's good to know when finding equivalent expressions. But on these problems, if we just taught that way, then understanding why 675 is our increase gets kind of lost. So here we do our new amount. We don't know what our new amount is yet, so that's just x. Our new original amount was the 5,175. Now this is a percent decrease, so that's minus our 4% of our original amount, which is 5,175. And so in order to solve this problem, I need to convert this 4% into a decimal, which means we need to divide it by 100. So dividing by 100 goes to the left twice, so that's 1, 2, which means 4% is just going to give us 0 and 4 hundredths. So this becomes x is equal to 5,175 minus 0 and 4 hundredths times 5,175. Remember, we need to do PEMDAS, so we don't want to subtract first. Again, right, if we're decreasing by 4%, that means our new amount is going to be 96% of 5,175. You can do that if you want. We're going to continue doing it this way. And so we do 0 and 4 hundredths times 5,175. And so again, I will do that on the side to show. So this becomes 5,175 times 4%, which is just 0 and 4 hundredths. So times 0 and 4 hundredths. Again, we have a decimal in our factor, so we keep track of our decimal places. And this 4 terminates in the hundredths place, meaning we have 2 decimal places. So 4 times 5 gives us 20. So regroup our 2. 4 times 7 is 28. Plus 2 is 30. So regroup 3. 4 times 1 is 4, plus 3 is 7. 4 times 5 is 20. And so we have 2 decimal places in our factor. So that means we need to move over to the left 2 times. and we end up getting that we actually decreased by 207. And so this becomes x equals 5,175 minus 207. And again, this right here is our decrease. 207 is the amount we're decreasing from 2000 to 2005. So again, maybe we do this on the side. So 5,175 minus 207, right? 5 is smaller than 7, so I'm actually going to have to regroup this 7, make it a 6, make this 5 a 1. 15 minus 7 gives us, I'm having a brain fart, gives us 8. 6 minus 0 is 6. This 1 is too small. 1 is smaller than 2. So I'm going to have to regroup from this 5. 11 minus 2 is 9. Bring down our 4. This means our new amount is 4,968, which means in 2005, the population, can't see that. In 2005, the population is 4,968. How much did they decrease by? Well, we decreased by 207 is the decrease. And honestly, MCAS can probably be like, hey, what is the total change, right? So if we increase by 675 here, and then we decrease by 207 here, what's the overall change? Well, it would be whatever 675 minus 207 is, right? Because we started at 4,500 and we ended at 4,968. So this means after, what is this, 10 years? After 10 years, our population increased by 468. But that's our video. Let's get it.